And welcome students to our next lesson on programming arrays. Today let's discuss privacy leaks with array instance variables. So getting started. In the previous chapter we explained why is a compromise of privacy for class to have an accessor or other method that returns a reference to private mutable objects. We call it a little subsection we talked about is called privacy leaks. And that's kind of what we're building on here. So as noted from there, an accessor method should instead return a reference to a deep copy of the private object. Now, at the time, we had in mind return the contents of a private instance variable of a class type. However, this same lesson applies equally to private instance variables of an array type. So just like how we would talk about privacy leaks with class types, we want to discuss it here too with arrays. So suppose that you decide you want an accessor method for the array instance variable class partially filled array. So you might remember that class that we had a while ago. Now you might be tempted to define the accessor method as follows. Public double get inside array return A. Now notice this is a problematic version. As indicated in the comment, this definition of problem, which is that the accessor method allows the programmer to change the array object named by the private instance variable A in ways that will bypass the checks built into the mutator methods of the class partially filled array. So to see why this is true, suppose we added this definition of the method get inside array to the class partially filled array, and then consider the following code. Partially filled array, leaky array, equals new partially filled array 10. Double array name equals leaky array dot get inside array. The variable array name and the private instance variable A now contain the same reference. So both array name and the private instance variable A name the same array. Using array name as a name for the array named by the private instance variable A, we can now fill the index variables of A in any order and need not fill the array starting at the first element. Now the issue is that this violates the spirit of the private modifier for the array instance variable A. For this reason, the accessor method get inside array should return a deep copy of the array named by the private instance variable A. So a safer definition for get inside array would be the following. Public double array get inside array. Recall that max number of elements is equal to A.length. So double temp is equal to new double max number of elements. For I is equal to 0, I is less than max number of elements. I plus plus, temp I is equal to A of I, return temp. So pretty much if you want the TLDR version of this, if you want to avoid privacy leaks, if you're using accessor methods, you want to create a temporary array when you are pulling those values. Now, if a private instance variable is an array type that has a class as its base type, then you need to make sure that copies of the class objects in the array when you make a copy of the array. So you have to make those copies. And of course, this is illustrated by the class toy example, which also includes a copy constructor. So if I look over here, you can see right here, here is my example. So this right here would be you have public toy example int array size, A is equal to new date array size, for int I is equal to 0, I is less than array dot size, I plus plus, A of I is equal to new date. If you look here, you have this constructor right here, public toy example object. So it calls a toy example object. Int length of arrays is equal to object.a.length. This .a is equal to new date length of arrays. For int I is equal to 0, I is less than length of arrays, I plus plus. This .a of I is equal to new date object A of I. So you will need both of these here in this example instead of just one, because you have to make copies of the class objects themselves. Now, as illustrated in the display, the copy constructor should make a completely independent copy of the array instance variable, that is the deep copy, in the same way that the accessor method does. Right? And of course, this point has also been illustrated by the copy constructor in partially filled array. And that's a kind of a quick one, folks. That's just going to wrap it up real quick there. So until next time.